Okay. We have pretty much a full class. Yeah, you gotta make sure you're ready to go. So we do know your exam is Wednesday. Today's the last day of stuff. If I was gonna pick out one lesson that was probably the most critical to your success on the exam, it'd probably be today. So you need to lock in, as you kids would say. Exactly. See what I say, it gets ruined. Don't worry. I have more to ruin for you later. But I'm not kidding. It needs to go well today. You need to pay careful attention. You need to have a good sense of what's coming your way after today. Okay? Let's talk about Friday. I actually thought you did pretty well Friday, but it might seem like a long time ago. I would like to just remind you of a few things. You know, when you're justifying each step, that's not a full-blown proof. It's very, very, very similar, but you were just giving rationale for all of them. A few things from me. Combining like terms is better than simplifying. Simplify usually means you're doing a calculation. So I would like for this to be combined like terms. Reminder, I do not want you abbreviating subtraction, multiplication, division. But I did tell you, instead of writing of equality the other day, what option did I give you? You could just put what? And it has to be done. I don't know if anybody remembers why, because not only is there properties of equality, there's also the same properties of congruence. Go.
Can we put prop instead of property?
Yeah, do property. Okay, I know I did prop here, but I'm the teacher. I get to. Okay. Yeah, just do it. You'll be fine. Okay. Well, thank you. That's why I'm here. Yeah, the properties of equality, because they're equations, we also have properties of congruence. Okay, now anytime you have substitution, I actually don't think you have much on here. Okay. Anytime you have substitution, you can just write substitution. You don't have to write the substitution principle. Okay? Good. These properties, I'm hoping you remembered them the other day. Symmetric property, now this is congruence. That means if A is congruent to B, then B is congruent to A. That is the symmetric property of congruence. Versus reflexive, that's everybody's favorite, where A is congruent to A. Please don't forget the transitive. The transitive property, we said it well the other day. Aria said it. When I said law syllogism, she said the law syllogism is conditional. So P implies Q, Q implies R, P implies R. The logic is very similar for transitive, but you can't say law syllogism. Okay, but why is it similar? A is congruent to B, B is congruent to C, therefore A is congruent to C. But they are different things, okay? Now, you will run into proofs on Wednesday. You do need to knock the proofs out if you want to get an A. Reminder of what's going on. Your statements on the left, your reasons given on the right. I don't know if anybody noticed, but this should just be a 6, not a 7. Okay? That's why there was somebody asked earlier, because guess what? This student pays attention, and she said, how come there are 6 statements, and said there actually aren't. They skipped over 6. Okay? So let's talk about proofs, because proofs can be very intimidating, but you're going to see more of them. This proof is not as intimidating because they gave you all the statements, and you just needed to provide the reasons. They also could have done a mix and match. And eventually in chapter 3, it's going to be, you're on your own, kid. Prove it. All the statements, all the reasons. We're not there yet. We will get there, but not yet. Okay, what should always come out first in every proof? Okay, now given is the reason, not the statement. So fill in the missing reasons. Given angle QWT and TWX are complementary. That's your first statement. It's one statement, and your reason is given. That's a point. If this is worth 8 points on Wednesday, which it could be, one of them is just copying the statements and putting given. Silly to not do that. Guess what your last step should always be? Where should you end up? What you're supposed to prove. What you're supposed to prove. Now you can't just write it and hope for it. That's just where you should end up, okay? So I do want to walk through this proof little by little and try to give you a couple of sense of what's going on. We start with their statement. Angle QWT and TWX are complementary. If I were in your shoes, and I was at one point, I would then say, okay, complementary, what can I pull out of my brain when I hear the word complementary? 90. So we are going to take this wording and translate it to the actual math. The measure of angle QWT plus the measure of angle TWX is 90. What allows me to say that? Definition of complementary angles. I move from words to the math because I know the definition. Okay? What did they do from here to here? Substitution, which again, you can just write substitution if you want. I want you to know why. Okay? Because angle QWT is represented by what? 2x QT. Yeah? See? Yeah, QT. There it is. Okay? Somebody. Exactly. Okay? And measure of angle TWX can be replaced with what? X plus 6. That's just straight substitution. Now the rest of it, the algebra is fine. If you couldn't do this, you wouldn't be in this class. Okay? You can do this. You need to tell me why they all work, and it's annoying, but it's line by line. You can do it. This is combining like terms. Okay? Now, I don't want you abbreviating like I did. That's why you shouldn't abbreviate sub, because what does this actually stand for? Subtraction. Okay? I subtracted 6 from each side. That's subtraction property, equality. What's the last step? Division property, equality, QED, which we'll talk about today. Yes?
On the test, are you going to have to do the statements as well as the reasons, or is it going to be the statements will be given and the reasons will be?
You will probably see a little bit of a mix and match, okay? Probably like this. Okay? You're not ready for a full-blown make it up on your own proof, at least in my opinion. We'll find out though. Okay, now this one I love. This is a mix and match, meaning you have to give some reasons and give some statements, okay? This is overall just helping you learn how these things go. So we always start with the given. Then usually we have to apply a definition or some background knowledge. There is some substitution. I don't know if you noticed, but there's a few things. I actually went back to the given a second time, okay, in order to get the other side. Okay, now this is a good example of actually simplifying. Okay, when I simplify from 8 to 9, we're just doing 6 times 3 plus 5. That's simplify. Okay, don't just write simplify and all the other ones thinking it will cover it. It won't. Okay. Now, I did go to the Bills game yesterday, and it pains me to say this, but this is the lot that we got put in, which was not intentional. And I just was shaking my head. My wife was like, why? And I said, I actually don't know why, because I don't really get it, and I don't really like it. So she's like, let's take a picture. Do you want to take your picture in front of it? I said, absolutely not. But I'll take one and show it to my students, and it's right there. It's also right there. Painful. Painful. All around. Okay, good. We move on. Now, yep. Yes, I put the heart hands around the algebra. It's actually hard to do. Please solve both of these. Don't let me down. Don't let me down. You know what? Let's just say just you. No friends, no enemies. Just you. Let's see who remembers their algebra. And that we need to do. You're going to park in this spot. I'm like, what's that now? Do you have space in any other lots? No. Are you sure? Yes. These were real conversations. Do you like what I did with the hard hands?
No.
What?
It's kind of ugly.
Yeah.
Well, sometimes.
I hate it.
Well, okay. You know what?
It doesn't even work.
Shh. Listen, I love a good hate, but not here. If you're gonna hate, you better get these right. I'm not reteaching you how to solve systems. I'll remind you, but we're not gonna relearn this stuff. There's enough people that will remember how to do it. Can you do both of them? I kept it really simple. I doubled the top equation. And then what operation can I use to get rid of the x? Oh, keep it real simple. You could have multiplied by -2 and added. That's actually what I normally do. So if you do that, you end up with 9y is 36. I got y to be 4. Anybody get y to be 4? Friendly reminder, we're not going to relearn this. We will refresh, we will not relearn it. Okay, and then how do you get x? Plug it in. I would do the top equation. So 5x plus 4 equals 9. I got x to be 1. Again, if I didn't think you could solve these, wouldn't have you in that seat. Now, you might look at it and say, geez, I was good at this last year. It's been a while. That's fine. But we're not going to do a whole new lesson on solving systems. We learned that last year. Okay, we did a lot of it. Okay, now there's a lot of options for the second one. Does anybody just want to tell me how you could start it? There's like 3 or 4 different ways you could probably start it. Maddie,
I solved by like a y equals.
did you solve the bottom one?
Yeah.
Okay. 2 ways to approach the bottom. Did you divide it down?
Yeah. By
Okay. Maddie wanted to substitute, which this will come up again, so you divided it by -2. So she got the bottom equation to be y equals -2x, and then where are you going to throw that -2x? Into y up there. So 8x minus 6x equals 1. 2x is 1. You get x to be a half. And then you could probably just plug it into that new equation that you got. Anybody have y? Come on, you were good at this last year. -1. That student in period 1, you know what she did? Rather than cut this in half, she doubled it. So it was 8x equals -4y. Then she threw -4y just in for that 8x. I know, I said, you must have had a really good Algebra 1 teacher. Okay, it worked out. Okay, now, I could spend a while on this. Just let it be known out there. You know how to do this stuff. You might be like a kind of rusty. It's not going to be a day where we relearn systems. Okay, we just did too much last year. This elimination was good. We also could have substituted. I guess if you did this top one, you could subtract the 5x over and then plug it in there. I don't know if anybody did that. That works good. Okay, same answer. Cool. We are going to talk about theorems today. Just warning, there are a variety of theorems you're going to need to know for Wednesday. The good news is after today you will know them. Okay? A theorem is any conjecture or statement that you can prove. The Pythagorean theorem can be proven. Okay? Has anybody ever seen this guy before? Do you know what this is? Did you ever notice that like there's like a triangular like face?
How does he get on his shirt?
Now you know. Okay? Yeah. So, the Pythagorean theorem, which is a theorem that you know, a squared plus b squared equals c squared, can be proven. Anything that can be proven is a theorem. Okay? Now, you might not necessarily know some of these, but we'll talk about them now, and then we'll try to keep them all straight. So this is true or false. A postulate. Ooh, we learned that a while ago. Anybody remember the other name for it? Axiom. Is a theorem. True, false? Anybody remember what a postulate is? Audrey, go ahead. You're talking.
Something that's like always true, but you don't, like, you can't prove it.
Exactly. A postulate is a given. It's something that's true that we don't have to prove, usually because we can't. It's just accepted as truth. We'll look at some examples in a moment. Okay? A theorem may contain definitions. That actually is true. It's really a proof of a theorem can contain definitions. And an axiom is a theorem. No, because a postulate and an axiom are the same thing. Okay? These are all postulates at the bottom. These are all postulates. Quickly fill them in. You'd be surprised. They're actually not very difficult. Just you. These are all postulates. Choices are lines, planes, or points. Oh my. Pretty good. Lions, tigers, bears, oh my. Lines, okay, that's good. Just take my word for it. All right, let's see here. Simon, the first one. Through any two, there lies exactly one line. Again, that is a postulate. It's true. We can't really prove it. There's not a good way to prove that postulate. But we know it's true. We accept it. We're glad we don't have to. Oscar, number 7. If two distinct lines intersect, then they intersect at exactly one point. It is not planes. Okay? Catherine, if two distinct planes intersect, then they intersect in exactly one line. The last one's a dead giveaway if you're looking at the board, because I put the purple up there again. Points. All of those are all postulates. They do not need to be proven. They can't be proven. They're accepted as true. You should love the postulates because you can just quote them as truth and I have to accept them. Problem is we're going to have to prove a bunch of things today. Now, speaking of proofs, what I'd like for you to do is look at this proof, which proves that 1 equals 2. And I want you to, with somebody around you, go line by line and see if you can find the error. Circle the error. If you find it, circle the error.
In what world is the number I think it's right
Okay, now let's talk reality time. You're allowed to, by the way. It was like more than half the class in period 1, maybe about half. Is anybody not able to really find a mistake that they didn't like? You can be proud. It's okay. Put up. Anybody just not. You weren't able to find a mistake, and the given is not a mistake.
Yes.
What about proud? It's okay. It's actually a convincing bad proof. So if you have your hand up, that means in your world 1 equals 2. So good luck in that world. Okay. No, the given. No, the given is not going to be false, okay? And when you're trying to prove a concept, you can actually start with your own given. It's just, it can easily fall apart, okay? So no, I wouldn't give you something like that. So everybody else, when I point to it, there's like one that's really a big mistake. There's one that I think is kind of sketchy, but it's not really a mistake. When I point to the line that you think the mistake is in, you're going to raise your hand, okay? The given is fine. You're allowed to say given A equals B. A is not 0, B is not 0. This is fine. Good. So it's kind of sketchy to me, the fact that they're subtracting a squared and not a. That's not wrong, but there are issues that happen. Because when we have the subtraction property of equality, we typically don't subtract the square. So it's iffy, but it's fine. Okay, they wanted this to be the mistake earlier. The factoring is fine. I taught you the factoring last year. What's the GCF of this? A? This is the difference of squares. B plus A, B minus A. The factoring is fine. Put your hand in the air. The mistake happened. Does anybody know why you cannot divide the way that they divided? Norm.
This is kind of a guess, but if it equals 0.
Because what did they divide each side by?
B minus A.
They divided each side to go from here to here. They divided each side by B minus A. But in our given, A and B were equal. So B equals A, which means they're dividing each side by 0. Okay? Which you're not allowed to do. It's a sneaky proof. It's not easy to find the mistake. They had a number of you convinced that 1 did in fact equal 2. But they violated the division property of equality when they divided by B minus A because they started with A equals B, which means they divided by 0. Okay, can't do it. Okay, now how many of you thought just the given was, you just didn't feel like turning your brain on, okay? No, you had to look at the whole proof, okay? Or you looked through the whole proof, couldn't find anything, you're like, it must be the given, but the given was.
Yeah.
So, good, cool. Now, let's get to theorems that are real or proofs that are real. Now remember, I'm not going to lie to you. I never lie to you about your tests. You need to know every theorem we talk about today. Like, you have to know them. And it's good to know them because you have 48 hours to be aware of them. The first is the vertical angles theorem. It states simply that vertical angles are congruent. So 2 is congruent to 4, 1 is congruent to 3. We use this one enough where I will let you abbreviate it VAT, vertical angle theorem. I actually taught this to you last year. I think Ms. Galbraith taught this to you. When you have this, 1 is congruent to 3, 2 is congruent to 4. Reason, vertical angle theorem. Vertical angles are congruent. Now we're going to prove the theorem. I'm not going to lie to you. I let them try this a little bit on their own in period 1. I thought it was a mixed bag. I'm going to let you try it as well, but I'm not going to give you like 25 minutes. I want you to see if as a group, you can fill in the reasons for everything. They have all the statements. I want you to see if you can follow the proof and decide on the reasons together. Take it from the top. Go ahead. I'll get you started. No, that's too much. You know what? I'm being too much.
You're too nice.
Being too nice.
No one lost that.
It's substitution.
You're substituting. Okay, what's the reason?
No, but that's what we were saying.
That's the definition.
I think this one's the definition of vertical angles, and this one's the definition of the
That's
next
gross.
What are we on?
It's possible you know some, even if you don't know others. It happens.
What's the measure?
That's it. You're trying to figure it out. That we don't have time for. Yeah, just take that. You get a chance.
What's the angle addition part? No, it's the substitution.
I think it's substitution. Yeah.
You want to keep trying on your own, or you want me to intercede? No. You can't say no. You want? Okay, go ahead. That's fine.
I'm writing a statement. That's the
Give about another minute or two. See where you landed.
I said substitution property of the
It's addition property. Whatever. It's
Yeah.
Last minute. See where you land. I will, because some of you are struggling, I will give you your first reason. There.
You're so
I don't ever want to hear I didn't give you anything. It's like the giver, but Alright, pencils down. Here we go. Now, pencils down. Okay. Now, again, this is still just, they gave you all this, and you come up with this. They might give you this and ask you to come up with this or a mixture. At some point, you will be thrown into the deep end. You're just not there yet. You should start to see some patterns with these things, the way that they flow. Okay, now hopefully none of you wrote down vertical angle theorem. That's literally what we're trying to prove. So if you wrote that, it's going to be wrong. You might have to make a change or two, maybe not, we'll see. Angle 1 and angle 3 are vertical angles, that is given. That's always going to be the way you start out, okay? Angle 1 and angle 2, also angle 2 and angle 3 are linear pairs. That is true. By the way, all of this is true. Does anybody have a reason for it? How do you know that? Apparently none of you know that. Joe? Definition of linear pairs. You have a diagram. You have a diagram with two angles next to each other that form a line. That's the definition of linear pair. Measure of angle 1 plus measure of angle 2 is equal to 180. Measure of angle 2 plus measure of angle 3 is equal to 180. Now you have to think about what you know about linear pairs and why they wrote that. Jonah? We already wrote that. Now, nope. What are we substituting? No one else? What else? Definition of supplementary angles. Supplementary angles. Supplementary angles, by definition, their measures add up to 180. We haven't even got to the tricky part. I think the next part's the trickiest. This is how it all flows. Measure of angle 1 plus the measure of angle 2 equals measure of angle 2 plus measure of angle 3. Nora?
Addition property of equality.
It is not the addition property of equality. Gemma?
Transitive property.
Of equality.
Oh, yeah.
Wait, Gemma, why is it the transitive property of equality?
Because I honestly don't.
Does anybody know why it is? It is. Okay, what else? So if the measure of 1 plus the measure of 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180, they both equal 180, therefore they equal to each other. Yeah, it's tricky. Did anybody write down substitution for that one? Nice try, but what are you substituting? Exactly. Exactly. Huh? It's okay. I think that's the trickiest part. Now the rest, hey, you can follow the rest. You could have skipped to this one. If you didn't know some of these, you could have got this. Measure of angle 2 equals measure of angle 2. Reflexive property, equality, right there. Yeah. No, these are flipped. These are flipped. I changed fonts and then they were like not even lined up earlier. This is reflexive, then subtraction. Actually, I could just move them like this. Subtraction property of equality because you're subtracting from each side. You have to state measure of angle 2 equals measure of angle 2 so that you can subtract the same amount from each side. A lot of you will think you're done here, but you're not. You're so close. We don't want the measures equal. We want to end with a congruence statement. Anybody have a last one? Definition of congruent angles. Yes! The definition of congruent angles which I believe we hit early in chapter 1, are angles that have the same measure. Maybe it was chapter, maybe chapter 6. Shh, you stop bragging. No one got all 7 for 7. I would have to ask. I would expect you to, okay? And we're still not done because we didn't write down what at the bottom. Anybody look up QED? It's Latin. Go ahead, take a spin at it. How do you say it? Close enough. What does it actually mean? Which was to be demonstrated, or that was which to be proven. There's not even a form. I'm not a big Latin person. There's not even one agreed upon English translation. Basically, it means this is what was supposed to be proven. You do write QED at the very end. Okay, that's something that you should do. Okay, you don't never have to quote the Latin to me. Okay, so now you can use the vertical angle theorem. We just proved it. Okay, let's talk about using it. Now, questions like using it, you should be able to handle. I gave you stuff like this last year. We're going to do a little together, a couple on your own. When they're just asking you to use it, primarily algebra, but you need to know what you're doing. Look at that diagram. Those angles definitely are best described as, and we just did this painstaking proof that the measure of vertical angles are best described as, and so without quoting anything, I can set 3x equal to 4x minus 22. I can get x equals 22. I'm on my way. If they wanted me to get both angle measures, I could plug them in. This is 66 degrees, and then 4 times 22 minus 22, also 66 degrees. They didn't ask for it, but guess what each of these is? What are each of these?
114.
Good. So I'm going to warn you. Questions like this, they're just as much algebra-based, but you have to know how to use the theorem. There are 2. I think this one's not too bad. I think this one is difficult. You're going to work on both of them. You have to be productive because we have more we need to do. Okay, so work through this one, solve for x and y, and then the second one is tricky. You got to really work for it.
That equals 32. Oh, plus 32 equals. What do you?
Okay, wait, so this is 32, right?
X equals. I was hoping for or 9x plus 4 equals 35.
Come on, stay focused. The second one is tricky, but doable. First one's not too bad.
I got it 3y plus 10 equals x. You know that. So then, what goes below? How do we do it like close your eyes? So then 3x minus y over 3 x equals y plus 10 equals what do you think? Wait, we have to
Oh,
Anybody feel good about the first one? You want to tell me x and y? Akil.
X equals 6 and y equals 10.
Can I see hands up for y is 10, x is 6? Yeah, I don't know how you did it, but the angles are vertical. I actually did the right angle first. 5y plus 8 and 32 make 90. I quickly got y. And then these two angles are congruent. Set them equal. Solve. That one should be good. The second one is messy, but it's doable. You just guys take a little time on it. You're not going to have it done in like 5 seconds. So keep working on it. What?
What's 180 times 3?
Oh, you can't do that off to the side. Yeah.
Wait, okay, so
Yeah, it's covered.
So what's 900? So I kind of learned that. How are you in this road? That's a really good question. I don't know.
Searching why was always
Last call for that one. I'm taking it off the board in a second. You should keep working. If you get the next one, let me know. I'll check it.
DC's pushed on.
What the bird? What if we just put them all together into one bunch? I think it's false. Why?
Okay, what is 170 divided by 1?
Why equals false? And then okay. Why then what's false?
X and Y.
Okay.
I'll take that one.
So the X is
And now you want my help? That's
No. Why are you
Couple more minutes. If you're done, I can check it. If you finish, you can start looking at the proof. But
You just said you.
okay, every single question. And so you're what's the day? Yeah. Exactly.
Okay, well, I don't know why. Okay, never mind. We can find you right now.
Just sweet.
I win.
On B doesn't mean any of that. On B means like what? Yes. It's Belgian.
okay, we gotta move on because we do have a couple more things we need to do. But hey, I can get you there. So this is why I did the systems warm up with you. Hey, this is why I did the systems warm up with you. Now they didn't ask for reasons, but I wrote them just to show you. The first thing I noticed, these two are congruent because they're vertical. It's like what we've been doing most of the class. That doesn't help me yet, so I need more. I noticed that this makes 180, so I added 3x minus y over 3 plus 3y plus 10 equals 180. This is enough information. I used substitution. Guess where I took this guy and put it? In for x. And then from here, it's just an algebra problem. Okay, but that's why I did the substitution problem with you earlier. Okay? You solve it down, which is doable. It looks way worse than it is. You do get y equals 12, and then you can plug back in and get x is 46. It even checks. The nice thing about these is if I plug them in, I should be fine. So if x is 46, let's see, 3 times 12 is 36 plus 10. This is 46. And then if I subtract, multiply by 3, do that? Yeah, 134. Perfect. This is a doable question. Just please look at it because we got to go on. We got another big thing we need to do. But it's very doable. The vertical angles show they're congruent. This shows me, their straight line. I substituted this guy into there. The rest, you're off and on the way. Okay, questions about that one? It takes longer. I told you the first one was real quick, and then this one took a minute. You'll know if you run into one of those. Okay, now we have a couple more theorems, and as I mentioned, you need to know these. Here's the good news. Most of them are going to appear obvious, but you still have to be able to quote them. Okay, theorem 2.2, congruent supplements theorem. If two angles are supplements of the same angle, then the two angles themselves are congruent. I'm going to show you what it means, and you're going to be like, duh. But you have to be able to quote this. It's called the congruent supplements theorem. So what does this theorem mean? If 3 is a supplement to 2, and 3 is also a supplement to 1, then guess what's true? 1 is congruent to 2. The logic behind it should make sense. Just throw in numbers. If 3 is 130 degrees, then this is 50. And if this is 130, that's 50. Therefore, they're congruent to each other. Okay? That's called the congruent supplements theorem. We're not going to prove it. Okay? Actually, we're going to do this one or we're going to do the complements one. Okay, we're going to prove one of these. So if we have that, we also have the congruent complements theorem. If two angles are complements of the same angle or congruent angles, then those angles are also congruent to each other. Same logic. If 2 is complementary to 1 and 2 is also complementary to 3, then 1 and 3 are congruent to each other. The logic should make sense to you. Okay, but again, why do we need this? Because we're going to be going through proofs, and this could be a reason for any of the things that you know. Okay? So we're only going to do the complements theorem. We're not going to do the supplements because it's basically the same proof. Okay? Now you're going to help me with this one. It's the opposite. They gave you all the reasons, and you're going to help me give all of the statements. So our goal, given that 1 and 2 are complementary, and 1 and 3 are complementary, what's our goal? To prove that 2 and 3 are congruent. Okay? They gave us given. We have to provide the statements. What are our first statements?
Angle 1 and angle 2 are complementary.
And?
1 and angle 3.
Yep. Remember, if this is worth like 8 points on Wednesday, step 1 is just getting the given and the reasons down, the statement down. This one should help too. I need you to start to see some patterns here. You don't always begin with the definition after that, but isn't that happening a lot?
Yeah.
That's good. It's not always going to be the case, but still. So now they're going to go definition of complementary angles, and then want to take a swing at this. I don't know where you're going to get there. Catherine.
Angle 1 plus angle 2, measure of angle 1
Good
and measure
fix.
of angle 2 equals 180, and measure of angle 1 and plus measure of angle 3 equals 180.
Good fix, except now we got to fix the 180, make it 90. Good.
Right.
Now it's okay. Got it. Did you notice her correction? She started to say angle 1 plus angle 2. What did she immediately backtrack and put in? Measures. That's the definition. It's required. Good fix. Transitive property. Now they made a mistake, and I didn't feel like fixing it. They said transitive property of congruence. Look at our statements. Guess what it should be? Anybody know what it should be? Should be equality. Okay? Statement? Well, I need some people jumping in on this, otherwise I'm not going to be sure if you're making any progress or on that. Fidelis?
Measure of angle 1 plus measure of angle 2 equals measure of angle 1 plus measure of angle 3.
Good. That's the transitive property of congruence. Measure of 1 plus measure of 2 equals 90. Measure of 1 plus measure of 3 also equals 90. Therefore, they're equal to each other. Next one we should all know. We're all going to say it together. Everybody hates the reflexive property. They're like, why? You have to, because of what we're going to do next. What are we going to do next with it from each side? subtraction property of equality. So what's our statement? Measure of angle. We are so close. The last is the definition of congruent angles. Angle 2 is congruent to angle 3. And one more. QED. You actually have to have it. Silly. That's actually your final point. Put in QED. It's the only way to know that your proof is closed and done. Okay? Now we're not going to do the congruent supplements theorem. It is the same proof, except you would start with the 180s instead. So we're not going to prove that one. But these are ones that you quote. Okay, they're ones that are given as reasons. Now we have a couple other ones. These are really quick ones. Theorem 2.4. All right angles are congruent. That's a theorem that you need to know. It sounds silly, but remember what these are. These are reasons. So when you're trying to make statements about things, and I ask you for reasons, and I'm going to ask you for reasons all the time, that's a theorem. All right angles are congruent. Okay? I think this is your last one on there, is it? If two angles are congruent and supplementary, and each angle, anybody know? It's a right angle. Very good. As I believe the last theorem for the chapter. Now wait, before we finish out, oh, there's still 2 questions left. Now you've got 48 hours to be aware of theorems that you need. Okay, there's plenty of ways to start looking through them. Okay, and to be aware. But I would know these theorems. I would know my definitions to the best of my ability, because all of them are things that are going to get you through this side. All things are going to get you through this side. Then there's going to be more and more, but you'll get there slowly. Okay? Now there's 2 questions to do. I'd like for you to work on them together. I won't lie to you. They're not obvious. The first one's okay. The second one's kind of tricky. Okay, please work through them together, and I will slowly reveal the answers on them.
Okay.
That's 90 degrees.
I don't know.
Come on. First one's not that bad.
Okay. Complement is 90. C quarter. 90 degrees. First one's not too bad. Second one's a little messy. Okay, so let's just like
No, 2/3 of x plus x equals 9 and each
so
I don't really
so you can substitute the 2/3.
She's not the only one to try this.
I try a lot.
How does it go?
Not very well. Usually my brother ends up yelling at me.
What do you think that is?
Also siblings do. First one's not too bad. A lot of you will fly through the first one. Second one's a little gross.
Wait. I'm sorry. It's C equals 30.
I don't understand the second one.
Guys, see thumbs up, thumbs down for the first one. I got 54 and 36. Ooh. Thumbs up, thumbs down. Yeah, this one's not too bad. I'll leave it on the board for a minute. Second one's a little messier.
What's 90 times 17? If you're maybe it's
Oh, here, I want to go back to pre-algebra.
Yes.
I'm trying to confuse why you're like first step in that one. Like two stars. I feel like I just
That's the way it reads. Angle A is equal to 2/3 of its complement. This is angle A. This is its complement, 2/3 of it. If the angle is A, its complement is 90 minus A.
Wait, I think I'm on something.
It'll help with the other ones too. First one's coming off the board. Please keep working on the second one. It's tricky.
So like actually if you
I expect you to be able to get it.
and you think about it,
If we multiply that twice.
Anybody that had the second one? I can check it. I know. Some of you are still working. Some of you are screaming.
I'm almost there.
Is 2/17 the measure of C? Wait, is 2/17 the measure of C? Isn't it like 2/17? It'd be like 2/17
If you're lost on the second one, you should start where I'm starting.
X equals 7.
What?
The measure of angle A.
You don't know. No, it's 2/17 measure of C.
Angle A is
It's 2/17 measure of C. No.
He is confused. All here you like C, B, and equals A and C. I'm confused.
It actually, no, okay. What is here? I get that.
Can't give up. Not an option.
Check the second one.
And then you multiply that by 7.
I did it.
Anyone else have an answer they want to check before I show them? We got a winner over
I
here.
did it. And it's right.
Winner, geometry.
Wait, I have seen
I feel like
Now, please watch. I will get you there. Isaac, you will run into problems like this. Actually, I'll tell you the problem is it gets wordy. The measure of angle B, the complement of A. I immediately wrote this down. And then I immediately wrote this down because it's true. Is 2/17 the measure of C? C is the supplement. I wrote this down. You have to be able to be willing to write this down. The reason the problem's tricky for people is it gets very wordy. So actually look at the highlighted piece. The measure of angle B is 2/17 the measure of angle C. This is the only equation you need to write. The wording gets in the way. I'd be writing this feverishly, by the way, if I had nothing. This is the measure of angle B, which is the complement. This is the measure of angle C, which is the supplement. Now, the solving is not great if you don't have a calculator, because obviously you have to navigate it. But it's also doable. Okay, you solve all these, you end up with the one angle being 12, the one angle being 102, and I believe the original angle A, 78. But I need you to look at this and understand You can solve this. You really should, though, as you're reading, don't move. You should write these down first, and then that's the only equation you need. Okay? We will review tomorrow.
I'm not even ready myself.